sections 2.1 and 2.2. This is, so we're moving on to chapter 2 here, which is about weighted voting. Okay. So the Electoral College is used to determine the winner of our presidential elections. So a little explanation from Wikipedia. Critics argue that the Electoral College is archaic, inherently undemocratic. It gives certain swing states disproportionate influence in selecting the president and vice president. But proponents argue that the Electoral College is an important distinguishing feature of federalism in the United States and that it protects the rights of smaller states. So the Electoral College is an example of a weighted voting system. So each state has a different number of votes that they have in electing the president. So California gets 55 electoral votes, Montana gets 3. The number of votes you get, the number of votes each state gets, depends on the size of its population. The bigger the population, the more votes it gets. Okay, so this is an example of a weighted voting system. So all of the voting systems that we studied in chapter 1 were one voter, one vote. Every person had an equal say. Okay, but in these voting systems, we're going to give more of a say to certain voters. And this is the classic example in our country is the Electoral College. We give some states more of a say than others. So this makes sense in certain situations. It makes sense that states that have more people living in them should have a bigger say. Maybe it's not the best solution, but it's okay, I get that, right? Then there are some other situations where it might make sense also. For example, 3 stockholders who own 10, 9, and 3 shares of stock. So the stockholders vote yes or no on motions, each share counting as a vote, right? So the more stock you own in a company, the more of a say you have over the decisions that company makes. So let's suppose that a motion needs 12 votes to pass. So 12 is called the quota, if you need 12 votes to pass a motion. So that means that 12 votes are also enough to defeat a motion. So we have some new notation associated with this new weighted voting system stuff. We always use square brackets to describe a weighted voting system. You put the quota first, so Q stands for the quota, and then W1, W2, W3, those are the number of votes owned by each of the players, and we usually write them in descending order. So here, we'll do an example. We have 4 friends who decide to start a company. We need $200,000 of capital to get this business off the ground. Player 1 puts in $80,000. Player 2 contributes $70,000. Player 3, $30,000, and player 4, $20,000. So they have their $200,000. And the friends decide that those who contributed more money should have more of a say in business decisions. So they say, okay, every $10,000 you contribute is equal to 1 vote, okay, in all business decisions. And the quota is going to be set at 2/3 of the total votes. Okay, so what are the total number of votes in this partnership? 20, yeah. So every 10,000 gets you a vote. So we have 8, right? The $80,000 gets player 1 8 votes. Player 2 gets 7 votes. Player 3 3 votes, and player 4 2 votes. That's 20 votes total. And then we're setting the quota at 2/3 of the total. So we have to take 2/3 of 20. What would that be? Somewhere around 6. That might be 1/3. I think that's 1/3. 2/3 would be double it. Yeah. So let's open a calculator, and we'll do 2/3 times 20. So 2/3 times 20, 13 1/3. So 13 1/3. So it's going to require 13 1/3 votes to pass a motion, but there is no such thing as a partial vote. So how many do we really need to pass a motion? 14. 13 is not enough because you need 13 1/3, but there's no such thing as a third of a vote. So we need 14 votes to pass a motion. That's what we call the quota. And the quota can be determined differently in lots of different situations. So sometimes you just need a majority. Sometimes you need 2/3. Sometimes you need unanimity, right? Everyone has to agree. So before we move on, Can anybody think of a situation where a 2/3 vote is required to pass a motion? Because sometimes in Congress, yeah. When if Congress passes, for Congress, they just require a simple majority to pass a vote, to pass a law. But if the president vetoes it, it can go back to Congress, and if they pass it with the 2/3, they can override a presidential veto. That's one of those checks and balances that we have. So sometimes in the Congress, a 2/3 vote is required. Anybody think of a situation where a unanimous vote is required to pass a motion, to make a decision? Courts, yeah. Juries require a unanimous decision to determine guilty or not guilty. So it all depends on the situation. For this particular business, they have decided 2/3 is the threshold. So 14 votes. All right, so our new notation to describe this partnership, we always have a square bracket, and then we put the quota first, which we know now is 14, colon, and then we list the votes of each player in descending order. So it's going to be 8, 7, 3, 2. So that describes that whole paragraph that we just read for number 5. That's how we write it without all the superfluous information, right? 14, 8, 7, 3, 2. That's all the important information. Okay, so there's some vocabulary that you should know. So when you get a chance later, look up these words in your book: dictator, veto power, and dummy. We'll use the words in some of these examples so you'll start to get an idea of what they mean. Now, what happens in this example of the 4 friends if we were to lower the quota to 10 votes? It was still, the votes are still 8, 7, 3, 2, but it only takes 10 votes to pass a motion. What would happen? What would be the practical ramifications? Anybody see a problem with having 10 as the quota? It's not a majority. Why is that a problem? Yeah. So if 10 people vote to pass the motion, how many people are voting to not pass the motion? 10. There's only 20 people. So if we lower the quota to 10, now we can have ties, right? That's not a good thing. So 10 votes means we have possible ties. Right? The 8 and the 2 could team up, and the 7 and the 3 could team up, and we'll never make a decision. Never be able to make a decision. So we always have to have the quota set at more than half. You need at least a majority for this system to work. All right, what happens if I were to raise the quota to 19? Said, okay, we're going to require 19 votes to pass a motion now. 19 votes to make a decision. Yeah. Yeah, if somebody thought something different. That's okay. That's okay. Somebody help Calix out. Really? Okay. What do you think, Mike? So everybody except for this guy with 2 votes. So if I add everybody else up, I get 8 and 7 is 15 and 3 is 18. So so 19 votes is basically the same as unanimous, right? So if I set the quota at 19 votes, might as well be 20. Might as well be 20. And what does that say about the relative power of each of the players? if you're requiring a unanimous decision, does the number of votes that each player has matter? No, they might as well just have 1, 1, 1, 1 and have the quota be 4, right? So might as well be 20, and all players have an equal say. What if I raise the quota to 21 votes? Say, okay, we can't decide anything unless we have 21 votes. There's only 20 votes, so again, we'll never make a decision. So 21. Never make decisions because there's only 20 votes. So when we're setting a quota, we have to keep in mind you need at least a majority. You have to set a quota so it requires at least a majority, but no more than all the votes in the system. All right, here's another weighted voting system. I have no story to go along with this one, but the quota is 11. Takes 11 votes to pass a motion. Player 1 has 12 votes, player 2 has 5 votes, and player 3 has 4 votes. What can you say about that partnership?
It's not fair because one guy is always going to be
Right. I don't know if that's necessarily not fair, but it makes player 1 a dictator. We call player 1 a dictator. And we call players 2 and 3 dummies. Not that they're dumb, but that they're like just stand-ins, right? Dummies. Okay, so now we're going to get into a way to measure power, relative power, in these weighted voting systems. So a coalition is any set of players who might join forces and vote the same way. So any set of players that might team up. Okay, so since coalitions are sets of players, we use set notation to describe them. It's a mathematical thing. So the example of a coalition of P1, P2, and P3 is that you just write those 3 players together in curly brackets. It's just a common mathematical notation. So a coalition that consists of all players is called the grand coalition. And a winning coalition is a coalition or a team of players, right, that has enough votes to win, that has enough votes to pass a motion. Any other coalition is called a losing coalition. And critical players, right? Any member of a coalition is said to be a critical player if the coalition must have that player's votes to win. So this will all get much clearer when we do this example. So you have the Parliament of Icelandia. It has 200 members. The Red Party has 99 seats. The Blue Party has 98 seats, and the Green Party has 3 seats. So decisions are made by a majority vote. So the quota would be 101. Because there are a total of 200 members, a majority has to be more than half, 101. Okay, so I want to fill in this table. I want to list all the winning coalitions, all the teams that can team up, and all the players that can team up and have enough votes to pass a motion. So what teams, what parties could team up and get 101 votes? Red and green. Okay, so we could do R, comma, G. We'll call them R and G. Red and green. And together they have 99 plus 3 seats, which is 102 votes. Now, if the red party said, I don't want to be part of this team anymore, I'm leaving, Does the Green Party have enough votes remaining to still win? No. And what if the Green Party did the same thing? If the Green Party said, I'm walking away from this partnership, Red would be left holding only 99 votes, which is not enough, right? So neither of these two can walk away. They need each other, right? So we say that they're both critical to this coalition. So when I list critical players, I'm going to list Red and Green. Neither one can walk away. All right, are there any other parties that can team up and have 101 votes? Blue and green, sure. So blue and green. Together they have 98 plus 3, which is 101 votes, just enough to pass a motion. Can either of them walk away from this partnership? No, so they're both critical. Anybody else? Red and blue, yeah, they have a lot together. Red and blue, 99 plus 98 is 197. Can either of them walk away? No, they're both critical. If either of them leaves, the other one is still a little shy of 101 votes. So red and blue are both critical. Are there any other winning teams? All three of them could vote together. Red, blue, and green. They have a total of 200 votes. Now, this is the Grand Coalition, all three of them, right? If red says, I'm out of here, I'm not playing on this team anymore, blue and green are left. Do blue and green have enough votes to pass a motion? Yeah, that means that red is not critical to this coalition. So we don't list them as a critical player. How about if blue walks away? If blue leaves, red and green still have enough. So blue is not critical. And if green walks away, red and blue together are still a winning team. So they don't need green. Green's not critical. So there are no critical players in the Grand Coalition. All right, so now we're going to define a precise way to measure each player's power using something called the Banzhaf Power Index. Banzhaf is just a mathematician who came up with this. So A is make a list of all the possible winning coalitions. It can be helpful to write down every coalition and then determine which ones are winners, or you could just try to write down the winning coalitions like we did up here. Up to you. B, find the critical players in each winning coalition. We've done that. C is to find the Banzhaf Power Index. You count the total number of times each player is critical, and you divide that by the total number of times any player is critical. So we're going to calculate the BPI for Icelandia here. So red, the red party for power, how many times is red listed as a critical player here? Twice. So we put that one in the numerator. And then how many times is anyone listed as critical here? 6 times. Denominator. So red is critical 2 out of 6 times. So that means that red has 1/3 of the power. All right, let's look at blue. Right, so blue is listed as critical twice out of a total of 6 times. So blue has 1/3 of the power. And then green is critical 2 out of 6 times also, 1/3 the power. So red, blue, and green, the 3 parties, each control an equal amount of power in this voting system. And the number of votes that they have can be quite deceiving, right? 99, 98, and 3 makes it look like the Green Party doesn't have a lot of power, when in fact, they have the same amount of power as the other 2 parties. Each party shares 1/3 of the power. And you can write these as fractions or as percentages. So if we wanted, we could write this as 33 1/3%. I can't remember which one my math lab asks for. I think it's fractions. So in a simplified version of the Celtics draft system, the coach has 4 votes, the general manager has 3, the director of scouting has 2, and the team psychiatrist has 1 vote. So of the 10 votes, a simple majority is required for a yes on a player to be drafted. So if there's 10 votes, how many are required to draft a player? 6. Simple majority. So my notation for the weighted voting system is the square bracket, then the quota, which is 6, and then the number of votes each player has in descending order, which is 4, 3, 2, 1. And then we want to find the Banzhaf power distribution for this weighted voting system. Okay, so I'll help you get started by helping you list all the winning coalitions, right? So I want to write down all the players who can team up and have enough votes to get the quota. So I like to start with, does any one player have enough votes? No. Okay, so let's look at 2-player teams. Are there any teams of 2 players that can get 6 or more votes? The 4 and the 3, that's player 1 and player 2. Any other teams of 2? Player 1 and player 3, the 4 and the 2. Player 1 and player 3. Any other 2-player teams that can get 6 or more votes? No. Okay, so let's look at 3-player teams. Okay, 3 players that can team up and get 6 votes. 1, 2, and 4. Sure. Any other 3-player teams? 2, 3, and 4. That's the 3, the 2, and the 1. Anybody else? One, 2, and 3. So the 4, the 3, and the 2. So we have 1, 2, 3, 1, 2, 4, 2, 3, 4. Are there any other 3-player combos that would work? 1, 3, 4. Yeah. Is that it? I think that's it. Those are all the 3 players. And then we always have the grand coalition, right? The 4 players could all team up together, and they will obviously have enough votes, oops, to pass the motion. Player 1, player 2, player 3, player 4. Okay. Now, I want you guys, now that we have this all written out, go through each winning coalition and circle any player that's critical. So for the 2-player team, player 1 and player 2, can either player walk away? No. So they are both critical. So you're going to go through each winning coalition and circle any player that's critical. So player 1 and player 3. It's a 2-player team. Can either player stand alone? No, neither one can leave. They need each other, so they're both critical. Now the 3-player coalitions are a little harder. You have to check each player leaving individually. So this player 1, player 2, player 4. If player 1 left, only player 2 and player 4 remain. Do they have enough votes? 2 and 4 together have 3 and 1 votes, so they only have 4 votes. So that means that player 1's critical. Player 1 can't leave, or else the team will lose. What if player 2 leaves? Then I just have player 1 and player 4. Did they have enough? Nope. So player 2 is critical. What if player 4 leaves? They still have enough. Yeah, because they still have the 4 and the 3. They still have enough. The 1 can leave. We don't care. fine, leave, get out of here, right? So they're not critical, we don't circle them. So for 2, 3, and 4, that's the 3, the 2, and the 1, which is exactly 6 votes, right? So if anybody leaves, the remaining 2 don't have enough. So everyone's critical in this one. We need everyone to get to the 6. All right, 1, 2, and 3, that's 4, 3, and 2 votes. If player 1 leaves, do 2 and 3 have enough to? No. So player 1's critical. If player 2 leaves, do 1 and 3 have enough? Yeah, they have 4 and 2, so they still have 6. And if player 3 leaves, do 1 and 2 have enough? 1 and 2. If player 3 leaves, that leaves player 1 and player 2, which they have 7 votes together. So player 3 is not critical. Okay, they can leave. Good riddance. We can still win. All right, player 1, player 3, player 4. If player 1 leaves, that leaves players 3 and 4, which only have 3 votes total, so player 1 is critical there. If player 3 leaves, that leaves me with a 4 and a 1, only 5 votes, so not enough, so player 3 is critical. And if player 4 leaves, that leaves me with a 4 and a 2, which is enough, so player 4 is not critical. Okay, so with 4 players, the Grand Coalition, if player 1 leaves, do 2, 3, and 4 have enough to pass a motion? Altogether, they do. So that means that player 1 is not critical, right? What if player 2 leaves? Are there enough? Yeah. Player 3? Yeah. And player 4? Yeah. So no one's critical in the Grand Coalition. Anyone can leave, and the remaining 3 will still be able to pass a motion. All right, so then we measure power by fractions that use critical counts. Okay, so player 1, do it over here. Player 1 is critical 1, 1, 2, 3, 4, 5 times. Out of a total of how many times is everyone critical? 12. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So player 1 has 5/12 of the power, almost half. Player 2, out of 12 times, player 2 was critical 1, 2, 3 times. 3/12 of the power. And that fraction can be reduced. I'm going to leave it for now. I'll reduce them later. Player 3 out of 12 times is critical 1, 2, 3 times. And player 4 out of 12 is critical once. So this is the amount of power that each player has. 5/12, 3/12, 3/12, 1/12. What happens when you add up those 4 fractions? Yeah, you get 12/12, one whole power, right? 100% of the power. So it's nice to leave them as unreduced fractions at first, because then it helps you check that you did everything right, because everything should add up to 1, 12 over 12, or 1. But I do think that my math lab asks you to reduce these. So this is 1/4, and this is 1/4. I'm not sure about that though. Just read the directions. I don't know if they'll tell you if they want you to reduce the fractions. Okay, who has the most power? Player 1. Who has the least? Player 4. Were there any surprising results? 2 and 3 have the same amount of power. Who were 2 and 3 again? Let's go back to the GM and the director of scouting actually have equal power, even though we gave them different numbers of votes. All right. So I'm gonna have you work on a little activity. in your groups. Frontier High School has a school board that's made up of 3 members from Deerfield and 2 from Sunderland and 2 from Whately and 2 from Conway. Anybody go through the Frontier school system? Just 1 person. Wow. Okay. So I want you to represent this situation using the notation for weighted voting systems. Find how much power each town holds in this system. And then there's some questions about that power and whether it is appropriate. So go through, work in your groups. I'll come around and help.